Hi, welcome to today's video. Today we're going to begin really diving into quadratics. So we're going to talk about some quadratic function basics today. So first of all, the graph of a quadratic function is a curve called a parabola. So the shape of the graph is called a parabola. And you've probably seen parabolas before and maybe just not realized it. Um, if we throw a ball up in the air and it comes back down, that shape that the ball flies through is called a parabola. Or possibly you've seen a satellite dish. The satellite dish is in the shape of a parabola as well. So there are lots of parabolas out there. So studying them and how to work with them is actually an important thing. So we have several forms of a quadratic function. The first one we call standard form. And standard form is y equals ax squared plus bx plus c. Or if we write it in function notation, f of x equals ax squared plus bx plus c. A, b, and c are just number coefficients. So for example, y equals x squared plus 2x plus 1. Our a is the number in front of the x squared, which is just 1. B is the number in front of the x term, which is just 2, and c is simply our constant term, which is 1. Okay, our vertex for our quadratic or our standard form function is at negative b over 2a for the x value, and then for our y value, f of negative b over 2a. So in other words, take the x value, put it back in and to our function, and see what the y value is from there. Okay, the second form is vertex form. That is y equals a times the quantity x minus h squared plus k. You may remember we worked with these a little bit when we were talking about transformations. So if you remember, this moves the graph left and right. This moves the graph up and down. So for this, this would move our graph either to the right or left h units, and it would move it up or down k units depending on if k is positive or negative. Or if we were to look at that in function notation, f of x equals a times the quantity x minus h squared plus k. And our vertex, of course, is located at hk. So it's easy to find from our vertex form. In factored form, we have y equals a times x minus m times the quantity x minus n, or f of x equals a times the quantity x minus m times x minus n. This is also called intercept form, so it's important to know this one has two different names, either factored form or intercept form. And our x-intercepts are easy to find in this one. They are located at m comma 0 and n comma 0. So if we need to find intercepts, this form is very nice to use. And we will be working with this one. We will be doing a lot of factoring of quadratics later on. So the vertex is just simply the minimum or maximum point, just like when we were working with absolute value functions, and our vertex was our minimum or maximum value. Same sort of idea here. For our parabola, our vertex is located at either the minimum value or the maximum value of the graph. So I have a picture here. Here is a parabola, and our vertex is at the minimum, whatever x and y value this has. And same here, this one would be our maximum at whatever x, y, whatever point that happens to be. We also have another important thing when we're dealing with parabolas, and that is a thing called the axis of symmetry. So the axis of symmetry is just that line of symmetry of a graph of a parabola. And so it's important to know that when we graph a parabola and we have our axis of symmetry here, that it is symmetric around that particular line. So that will help us to find points and graph later on. Okay, so let's start taking a look at some examples here. First off, we want to take something and write it in standard form. So in our first example, I have one in intercept form that we are going to rewrite in standard form. And then we're going to identify the quadratic, linear, and constant terms. Okay, so if we have y equals negative 3 times x minus h times x plus 3, or sorry, x minus 8 times x plus 3, go ahead and write. I'm going to multiply these out using a table this time. Remember, you could FOIL or you could multiply vertically, whichever of the three methods you prefer. But I am going to use a table. So x minus 8 up here, x plus 3 down here, and then just fill in x times x is x squared, x times negative 8 is negative 8x, x times 3 is 3x, and negative 8 times 3 is negative 24. So go ahead and write those out. And remember, we did have a negative 3 out front here. So we're going to have to distribute our negative 3. But first, let's go ahead and combine those like terms. So negative 8x plus 3x is negative 5x. So I've replaced those with the negative 5x. And now let's go ahead and distribute. So when we distribute, negative 3 times x squared is negative 3x squared. Negative 3 times negative 5x is plus 15x. And negative 3 times negative 4 is plus 72. So this is now in standard form. We can now identify the three types of terms that they wanted, the quadratic, linear, and constant terms. So the quadratic term, of course, is just the one with the x squared attached to it. So in this case, our quadratic term is negative 3x squared. Our linear term, well, if you think of linear functions that we've been working with, we have an exponent of 1 on the variable. So here, this is our linear term because it just has an exponent of 1 here. So 15x is our linear term. And our constant term is just that 1 on the end with no variable attached to it. So in this case, our constant term is 72. One thing I should note, and I'm not going to do an example of one, but if we're in vertex form, say, for example, we have y equals 2 times the quantity x plus 7 squared minus 8. One common mistake that students will make is take this x plus 7 squared and not take care of it properly. So what this means is we're going to take x plus 7 times x plus 7. So you would go x plus 7, and multiply. Okay. Oftentimes, students will just take this squared and make this x squared and 7 squared. But that doesn't work because we're going to lose a middle term when we do that. So be very careful when you're multiplying these out. Okay, second example. For the parabola, find the points p prime and q prime that correspond to p and q. So if you remember back, possibly in geometry, you may have studied reflections. And when we had a reflection or a corresponding point through a line, we used the little prime symbol there to represent those. So p prime, if we look on our graph, p is over here at 0, -2. So 0, -2 is where p is. And so we're going to basically just reflect that point through our axis of symmetry. And our axis of symmetry happens where through the vertex, because it has the axis of symmetry has to go through the vertex for it to be symmetric. And our vertex is at 1, -4 in this case. So our point P is at 0, -2, and our axis of symmetry is at x equals 1. So that distance from P to the axis of symmetry in the x direction is 1 unit. So what we're going to do is just go one more unit past that, and that will be where P prime happens. So from 0 to 1 is 1, we go one more, that will be 2 in the x direction. So since P is 1 away from the axis of symmetry, P prime is also 1 away past the vertex. So P prime is at 2, -2. Okay, we can do something similar for Q. Q is at 3, 4. It's up here. And notice since our vertex's x value is at 1, our x value here is at 3. That's 2 units away. So we're going to go 2 more units in the negative x direction. So from 1 and take 2 more units back from there, it puts us at -1. So our Q prime is going to be at -1, 4. So since Q is 2 away from the axis of symmetry, Q prime is also 2 away, so that puts it at -1, 4. Okay, so now what we're going to do is we're going to start finding some of those just from the equation. So for the parabola, identify the vertex, axis of symmetry, y-intercept, and x-intercepts. So we have a parabola here, and it's the one that we're given. So we're going to take a look. Where is the vertex of that? Well, remember the vertex is simply the low point. It's this point right here. So it is at -1, -2, -1 in the y direction. So it's at -2, -1. Okay, and the axis of symmetry, remember, is that line that goes right through there. And remember, the equation of a vertical line is just x equals something. So in this case, it is x equals -2. And the nice thing is, we can just look right here. Since the axis of symmetry has to go through the vertex, the x value of our vertex will also help us find the equation of our axis of symmetry. So it's x equals -2. The y-intercept, if you take a look at the graph, where the graph crosses the y-axis, is right here. So that is 1, 2, 3. So it is 0 in the x direction, 3 in the y direction. So it's 0, 3. And our two x-intercepts, in this case, we have one located right here, one located right here. So this one is at -1, -2, -3. So -3, 0. And this one is at -1, 0. Okay, so there are the points that we were looking for that problem. Okay, in the next one, identify the vertex, axis of symmetry, and y-intercept of each quadratic. So now, instead of identifying it from a graph, and it's important to be able to identify it from the graph, but we're going to take an equation in standard form and find where all of those are without even having to graph them. Okay, so we have the equation y equals -2x squared minus 6x minus 34. So note that our a value, remember this is ax squared plus bx plus c. So our a value is -2, our b value is -16, and our c value is -34. So the x value of our vertex, like we mentioned earlier, is at -b/2a. So if I take a look, -b, the opposite of -16 over 2 times a, and a is -2. So we have -16 over 2 times -2. So if we begin to simplify the opposite of a negative, that makes this positive. Those cancel out. So we have 16 over -4. When we divide 16 by -4, we get -4. So the x value of our vertex is at -4. So now we need to find the y value of our vertex. Well, that is f of -b/2a, which -b/2a is -4. So we're going to find f of -4. So take -4, plug it back in here for x. So that's what I've done right here. -2 times -4 squared minus 16 times -4 minus 34. Simplify that. Remember that -4 squared, -4 times -4 is positive 16. And -16 times -4 is going to make this positive 64. So we've simplified a little bit. -2 times -16 is -32. Plus 64 minus 34, so that works out to be -2. So our y value of our vertex is -2. So remember, our axis of symmetry is simply x equals whatever the x value of our vertex is. Our vertex is -4, -2. So x equals -4 is our axis of symmetry. So that's pretty easy to find once we find the vertex. The y-intercept, remember the y-intercept happens at f of 0. So f of 0 happens to be -2 times 0 squared minus 16 times 0 minus 34. So basically 0 minus 0 minus 34, which is -34. So our y-intercept is at negative 34. And that is it. So we have found the three values that we were looking for there. Okay, moving on. Now we have one here in vertex form instead of standard form. So we have y equals negative 1/2 times the quantity x plus 6 squared plus 9. So remember, in vertex form, the vertex is at hk. And so we have a minus h here. So really, instead of being 6, we need to think about this as x minus a negative 6. So our x value of our vertex is negative 6. And our y value of our vertex is plus k. Well, plus k is 9 in this case. So our vertex is at negative 6, 9. A little bit easier to find the vertex in vertex form than it is in standard form. So if it's in vertex form, that's nice. Okay, our axis of symmetry, we'll remember our axis of symmetry is simply whatever the x value is of our vertex. So x equals negative 6 is where our axis of symmetry is. That's the vertical line at negative 6. And our y-intercept, well, remember our y-intercept happens when x is 0. So if we find f of 0, we're just going to put in 0 for x. So negative 1/2 times 0 plus 6 squared plus 9. Okay, 0 plus 6 is 6. 6 squared is 36. So we have negative 1/2 times 36 plus 9. And half of 36 is 18, and it's negative. So negative 18 plus 9, negative 18 plus 9 happens to be negative 9. So our y-intercept is at 0, negative 9. Okay, so we've looked at standard form, we've looked at vertex form. Now we need to look at intercept form. Okay, so this time we're going to add a few things. We're going to find a few more. In intercept form, we're going to find the vertex, the axis of symmetry, the y-intercept, the x-intercepts, and the minimum or maximum value of the quadratic. So we have one right here, y equals the opposite of the quantity x minus 3 times the quantity x plus 7. So remember, intercept form looks like this. And the intercepts are at m, 0 and n, 0. And remember, these are negative here. So since this one is already negative, one of our intercepts is really easy. It's at 3, 0. So our first intercept is at 3, 0. This one, if we look there, it's at n, 0. Well, since this has to be x minus something, x minus a negative 7 would be the same as x plus 7. So our other x-intercept is at 7, 0. So I have put those two on this graph just for you to kind of see visually. Here are our two intercepts. Remember the axis of symmetry, since these have the same y value, the axis of symmetry has to happen halfway in between those 2 points. So if we think back to geometry, to find the midpoint of 2 points, we add the 2 points and divide by 2. So I have taken x equals 3 plus a negative 7. I just took our our 3 plus negative 7, our two x-intercepts, added them together, and divide by 2. Well, 3 plus negative 7 is negative 4 over 2. Negative 4 divided by 2 is negative 2. So our axis of symmetry is at x equals negative 2. So that means, since the axis of symmetry has the same x value as our vertex must happen at negative 2. Okay? So to find the y value of our vertex, remember, we have to find f of negative 2 in this case. So if we put in negative 2 here, negative 2 minus 3 is negative 5. So the opposite of negative 5 times negative 2 plus 7 is positive 5. So negative 5 times 5 is 25. Sorry, negative 25, and then this makes it opposite. So the opposite of negative 25 is positive 25. So our y-intercept is way up here at positive, or sorry, our vertex is at positive 25. So it is at negative 2, 25. That's that point right there. Okay, so now think about our y-intercept. Our y-intercept occurs at f of 0. So if we put in 0 for x, we have the opposite of 0 minus 3 times 0 plus 7. So negative 3 times 7 is negative 21. The opposite of that is positive 21. So our y-intercept is at 0, 21. Okay, we already talked about our two x-intercepts, negative 7, 0, and 3, 0. And our minimum or maximum value. So real quick, I'm just going to sketch this graph. Since our intercepts are way down here and our vertex is up here, this is going to look kind of like this. Okay, so something like that. I probably didn't get exactly 21 for our y-intercept, but it was close. So our minimum or maximum value, well, in this case, since our graph is opening down, it's going to be a maximum value. And in the y direction, that is y equals 25. So this particular one, since it opens down, has a maximum value. All we have to do is look at the y value of the vertex. That will give us our maximum value. If it opens up, we still look at the y value of our vertex, but in that case, it would be a minimum value instead of a maximum. Okay, so just to recap, we worked with standard form, we worked with vertex form, we worked with intercept form. We found several different points. Next, what we're going to do is use those points to do some graphing. So I hope this was helpful. I look forward to seeing you again soon. Thank you very much for watching.